Good day, attendees. Hello, I'm Ravi, representing PyHub. And on this Sunday fun day, we are going to make this 2 hours a very good session for you guys. I'm very excited of this presentation. And last week, when I met Sudhir, and he told that we are doing waste to conversion of energy in Phovesto powers. So I was, Sudhir, wait, do you really convert waste to energy? Yeah, we are already doing the projects, was his reply. And without wasting any more time on this session, I'm handing it over to the Sudhir, the presenter on today's session from waste to energy conversion. Hi, Sudhir.
Ravi.
Yeah. Are you ensuring your time for our attendees?
Yes.
Yeah. Please do share your knowledge on what you're doing in the daily activities of host of powers, and we are happy to get the knowledge from you. Yeah. Please proceed.
I'll start with the presentation now. Yeah. So today's topic was on waste to energy power plants. Yeah, people are so much fascinated, and we are having so much uh, to know about it because waste to energy is a tedious one. People are so much so many people want to do things into it, and there are so many innovations going on. And the waste is typically people everyday people see that, and most of it is neglected, and that is what it is a vital part of humans. Yeah, so I think that's a key thing which we want to see. But as it is, we have shown like one man's trash is another man's treasure. So is it? Yes. So we'll go ahead and today's presentation, our agenda will be what is the waste actually, how do we define a waste, or what is the problem of the waste, and what are the traditional processing methods. So and what is the actual potential of municipal solid waste. So and how we can go about municipal solid waste power plant when we want to go about it, and what is the engineering behind it, and also along with the cost analytics, we're going to get on that. So coming to waste to energy plant. So Foster Powers is into many things in power plant construction. So we serve customers directly in power plant construction, power plant ANC services, energy auditing, and portable and compact solutions such as microgrids, portable PV solutions, portable DGs, all those things. So getting on to that, business to business solutions. So we do deliver to people in other businesses such as designing the plans, engineering the plans, project management, engineering, procurement, EPC services, installation services, um, AMC services to business people too, along with power plant simulations, such as like when you design a power plant, what is the actual load and how we going to cater with the production. All those things we can generate it, and the analytics of the plants. All those things we can provide it for business to business people. So let's head on with our presentation today on waste to energy power plant. So the common problem of everyone. I know today it's COVID-19, but still waste has been the single most problem for centuries ahead, and it will be for the centuries to come on. And it is quite astonishing that we buy million plastic bottles every minute across the globe, and most of it ends up in ocean. So the plastic bottles, which has high calorific value and which is having a very good energy content, it is all wasted up. So that's the resource which can be recovered, right? And it is quite surprising that by 2050, the total weight of plastic in the ocean is more than the actual fishes in the ocean, right? So that we have completely replaced it. The entire ocean ecosystem is completely going to change on that. And what about the remaining, which is ended in landfills, which is ended into our local communities everywhere. So that's the biggest problem for everyone. So that has to be taken care by someone. And this view I believe is not a new thing for most of the people. They might have encountered this numerous times a day, and I think everyone might have encountered this. But the thing is, this is the most neglected view too. We don't want to interfere into it. We just blame the person who throws the waste, blames it, but doesn't think that he has started the chain. So, with stakeholders such as governments, the municipal solid workers, private entities, NGOs, all this thing, there are people who are trying to help with the situation. But this doesn't go well unless every person takes care of his waste in a proper way. So let us go through it. What is the actual problem? Like, okay, this sits there. What is the problem on the waste? I am just throwing it, right? So what possibly can it hurt us? The biggest thing people think about is it is what I don't see doesn't hurt me. The problem of waste is it's everywhere and we produce it every day on daily basis. Not even a day goes by without producing any waste. We may even go a day without eating or without sleeping, but we surely produce waste. So that's one thing for sure. And the most things which waste uses is the pollution is the bigger part, the larger part one, and everyone knows about it. Like the water pollution, air pollution, the soil pollution, everything is polluted. And out of that, people living to that a place where the bin has been collected, the collection bins are there. When a garbage collection bin truck goes or a car goes on, we get all these problems. Order. The first thing, the smell. We cannot stand the smell of it. The second thing is pests. There are so many insects and microorganisms, the infections, all those things. There are many cases where people are infected. The local communities are infected due to the landfills and poor management of municipal solid waste management. Uh, and the rodents is the biggest issue too, because the most of the Asian municipal solid waste is completely on organic side. The rodents are attracted towards it, are acquiring a whole different sign of complete circle, like a food circle, like the rodent comes first, few reptiles come to take it on, and this has become a huge menace and a threat for that particular species too. And during this rain seasons, leachate, the water flows, the water makes the flows across the streets and the user communities, all these things. It's a big issue for people having this leachate issue. So we need to overcome those things in municipal solid waste management. So we'll go by generation of waste. Where all we are generating the waste. So we have categorized it into four in our philosophy. So establishments such as industrial outlets, where the waste is completely sorted, regulated, and it is completely calculated. We know what is the waste it is going to generate and how much it is going to generate and when it is going to generate. So it's conventionally easy to recover in those places. High recovery rate is there, and people mostly prefer this kind of waste to process in their recycling units or waste energy units. Everywhere, the most preferred is the establishment ones. Agricultural one, on the other hand, is seasonal. So once the cultivation is over, the harvesting season comes, the waste is generated there. And day on day, the weeds and the cattle feed, all these things, it's all on the same lines. So it is everything goes back to the same thing. It is all organic waste and wet waste, and it can all be digested in a biogas digestion. So it is one of the preferred one compared to industrial. This is not that much preferred, but still people go by this, and this varies across the regions. Agricultural, for example, Chennai has zero biomass feed, whereas some other place, UP has higher amount of agricultural feed seasonally varying as we speak. And this is almost highly sorted too, because we don't get any plastics are something so frequently in agricultural waste. Most of it is completely, the 98% of the agricultural waste almost will be homogeneously organic, and the recovery rate is moderate. Still, the recovery rate is moderate because most of the agricultural waste goes into composting. The local composting bins, people just compost it, and some other farmers, once it is completed, they'll just burn it out. So these are the two methods farmers use for the organic waste. Either they burn it or they just make it to fertilize. So in most cases, people don't want to fertilize because of the time it takes and the amount of complexity they involve. Like they need to keep maintaining the compost, all those things. So they just simply burn it. So that's a big issue in agricultural waste. But apart from this, highlighted two. This is where the key problems lie. The urban place where the carts come, the residential waste, the schools, temples, churches, mosques, all these places generate space. People get to their public places, to the bus stands, railway stations, all these places, the urban areas. People tend to put waste in garbage bin, and that is collected on daily basis based on the generation of the garbage. So that is highly unfair because we don't know what people put today. The person may put a plastic bottle today, and tomorrow he may put a cardboard, or day after tomorrow he may put some food into it. So we don't know it. It cannot be chatted. The same person doesn't put the same thing every day. So it is completely high variability index. People like even when the government is trying to put up systems like having dry waste and wet waste, two separate bins, people are not able to follow that. And to be more specific, we are finding it hard to make people use dustbins first. So people are not using dustbins. They're not getting into at least this particular supply chain. It is not actually collected at least first. So that is the biggest issue there, and it is all mixed up. So it doesn't think like, okay, a person A comes and he puts everything in the right places. The person B comes, he misses it. He puts everything in one. So it's always mixed. It's a team play. We cannot have like, okay, well, I did sorting rightly and it doesn't work. No, everyone should do the sorting. Until it is done, it cannot be a homogeneous one. So, and the littering, the biggest problem is the littering. The littering is like as a picture indicates, and we might have seen in our highways when people are traveling, they'll just throw things out over the roads. And literally recovering this resource is highly tedious because we cannot employ people to go on and pick waste across the this highway lanes or some remote locations, because this places, just to recover that resource we are spending more resource, and equally we are spending more pollution. Just consider like when a truck moves there and to get this particular chunk, it is polluting more in by burning diesel than recovering the waste. So that is a tricky situation, and this is highly variable too. People just throw everything out. Well, littering, they'll spit, they'll throw papers, they'll throw water bottles, they'll throw food, everything. So, and it is highly mixed, and it is almost negligible recovery rate. So this particular segment, the urban and littering, this is what constitutes for municipal solid waste. The major of municipal solid waste comes from this urban garbage collection, and little to very less fraction comes from littering. So what are the traditional methods actually? Like people are not like, okay, the government is not like, okay, we are not going to do anything now. This is all to or on the people are have different methods of processing the traditional waste. It has started way before 1850s. So where the resource was scarcity, when people happen to look at the scarcity of resources, that is when people started to look into recovering the resource from waste. So these are the three golden R's: recycling, reusing, and reducing. The traditional method of waste handling is this three golden R's. So recycling process, reusing process, and reducing process constitutes to most of the actual traditional waste methods till date. So let's get into detail of it. So traditional waste processing, the first is reusing. So this is why we have put reusing in the first phases. When you have used a commodity, Let's just say you have used a paint bottle, you have purchased a paint bottle, you are using it to paint your home, and you have completed the bin is empty, the entire can is empty. So literally, next thing people will think is, why just put some mud into it and plant a plant a seed or something, plant a fruit plant or something. So they will just get with that. That is the first step of reusing. Once the commodity used for particular function is completed, then instead of throwing it out, finding another purpose for that particular product. So that can be either by addressing the self needs, wherein in this case you can think like, okay, I'll just plant a seed which I need. But in other cases, like a community needs, for example, putting up using up the used tires as barricades across the roads and most of the parks and those places. We can use that particular resource to meet some other need. But this purely depends on the functionality of that particular product. So when designing products, the functionality has to be focused. Like for example, we are building something, for example, to hold something like a paint. We are building a very heavy material, like the tins, or the metal cans, or we are going to use the high density polyethylene plastic. So this particular things can last more than just holding it up. It will last longer than the paint itself. So this resources can have multiple functions. So afterlife, what is the function after the product is being used, and the durability, how long this will stay. For example, you just use a rubber band for some small temporary person, just you throw it up. That ends up in a garbage. So the durability, how durable is that particular product? That depends on whether it ends into landfill fast or it goes into reuse or recycle. So and the aesthetic appeal. People doesn't want to keep things which is not good looking. They'll just have it for some time and they'll just throw it up. So that accounts for a huge amount of waste too. And the marginal cost of it. When you are using particular, for example, the maintaining of this particular paint cans, it doesn't require anything. So we use it for a other purpose. So the same thing happens in all the things. If the cost of maintaining that particular reuse of the particulars makes sense than going for altogether a new one, people will tend to reuse it. If it doesn't make sense, people just throw it up and it ends up into the garbage. The other method is the most promising one, and most people are fascinated about recycling. People want to recycle everything on the planet and they want to reuse it completely. So the recycling goes into three different categories, like three different methods: primary, secondary, and tertiary. Is plain on simple terminologies. So primary is a closed loop one. So whatever, for example, you have used a glass bottle for something, you recycle it and it ends up again into a glass. So it is a closed loop completely, and the functionality serves the same thing every time it is recycled. For example, papers is recycled again into papers to serve the same purpose. So like that, it is a primary recycling method. Secondary recycling method, it has partial recovery, and it can be used for some other purpose. For example, tires. Most of the tires, when it is recycled, it goes entirely to into tire manufacturing process mostly. Some of it is taken out and it is treated to some other process, but most of it goes into the same process. So that is the secondary process where we use as an open loop. And the tertiary one is completely advanced ones where we convert the existing thing. For example, plastics treated to fit to make plastic roads in India. So that's the tertiary method of recycling, where we chemically process it to the actual material to serve other needs. And this particular recycling, there are quite a few challenges, because it is almost the recovery material is almost selective completely, because when a person puts up a recycling plant, either he may recycle plastic recycling plant, tire recycling plant, or he may use metal recycling plant, glass recycling plant. It is not interchangeable. It is not completely flexible with all systems. So, but our urban waste is completely mixed with all these things. So the traditional recycling methods doesn't go with this, and even the recycling reuse methods, if it is making any sense to that particular customer, it doesn't end up into the garbage. Okay. So the things which is not able to process in those two steps will end up into the other steps. like the reducing. So reducing is the place where we take it to composting or landfill, energy recovery, accelerated decomposition to have negligible little effect on the environment rather than keeping it alone. All these things is there, but this has a huge implication, and this is the most challenging phase, and people least prefer it. The least preference in sense when we generate the waste, we don't think on like okay how it is going to process, but after we have thrown out waste, we are concerned how it is being processed. So um, the stakeholder interest is highly important in this case. For example, the land has to be acquired to put this waste. The surrounding people, the neighboring landowners, all should agree for this. The local community should agree for this. The local, the people who are around that particular landfill, around that composting, all these people has to accept for this, or else there will be a huge implication because in Surat, Surat is one now the cleanest city in India, but laid back, there was time when Surat was so poorly managed in municipal solid waste, and it led to almost exodus of the city because of a plague. And people happen to get it. They happen to see to that their waste is managed clearly, and as a teamwork, now they have become the most cleanest city in the India. So, like that, the local communities, the stakeholder, everyone should come into play to efficiently manage this particular waste in this particular segment. If it is unmanaged, it will lead to disasters and huge environmental impacts. There are places where huge landslides happen, just garbage slides. We cannot say landslides. It is completely garbage. Garbage has slided over to the slum areas and killed hundreds of people in many places, like Philippines and those places. So government regulations are there still, but it's not so stringent. We can see like there are the famous garbage mountain of Delhi. Everyone knows about it. And just it has become a quite attraction for many people. And in Chennai, you can see a kilometer-long dump yard. The landfills, the dump yards, it's very amazing. And people, when they pass by that, they don't want to. Instead of passing by a landfill, people are willing to travel in a longer way. They can all the way reroute and go in a longer way than to have that thing. Just consider that. Like, just we were not able to pass through that, and when we want to process that, when we want to, local communities to be there, that is the quite a challenging situation here, and it has very huge environmental impact to it. It will completely decompose the groundwater systems, everything. So this particular place requires most of the innovation, and most people doesn't have much innovation in how to eliminate the landfill. They just take it out, burn it, decompose it, clear it or shed it. This is the actual way, but it is less impactful rather than leaving it away. That's for sure. But still, there are innovations needed in this segment, and I would like to personally ask students who have attended today to look into this particular matter. You guys can innovate on things. So anyway, this is the challenge. It is not that we have everything here on the planet. There are things. There are a lot of things which needs innovation. So this particular area is a place of innovation which many are needed. Even the developed nations need this. So let's just get into this. What is the potential actually? We have seen the threats, the sourcing, all those things. So yeah, that's a big deal. The waste is a big problem. Yeah, we understand that. But what is it actually have a potential? What does it has to unlock for us? How much does it matter? So we have just made a small graph into financial benefit as well as environmental impact through the different types of waste. So waste by natural activities, just like the leaves falling off a tree, the twigs, the birds, the bird droppings, all these things are little risk. It doesn't have any risk at all. It normally decomposes on its own and doesn't have any financial benefit too. And most people are not worried about that. It goes within days. The next thing is agricultural waste, which has low risk because anyway, because of this is completely biodegradable, it decomposes even in the land which is being left alone. It decomposes and becomes a manure and goes by the natural process. So it doesn't have any large environmental impact in the immediate front. And financial benefit is a moderate one when we happen to put up into a biogas digester and get energy out of it. It instead of going out of for nothing, it will pay off something and it will become a manure and it will be used. So that is one part. But the industrial waste is as revered and proven system. Most people want that because it is highly organized, completely recoverable. Mostly the scrap or scrap metals, all those things, all is completely recycled and it's a dime for money. So everyone wants it. It's it. It's all set. The high risk in environmental impact and the complex processing is urban waste. So that is way our financial benefit is not so big, but it's considerable. And we will have a cost benefit analysis. For example, how much does it cost to run a plant and how much can it financially benefit? We'll show it at the end. Because of this, there is something we pay, like the tax, Swachh Bharat tax we pay to handle our urban waste. So that puts this particular urban waste into a profitable segment. So, and just not considering about India, across the world, 27 billion tons of waste will be produced every day by 2050, out of which Asia is one of the leading waste generator and major contributors from China and India. And a study from 2014 happened to indicate 51% of our waste in India is organic and biodegradable. But that process is not going to remain because of the remaining commodities of 17%, which consists of plastics, most of which is plastics, single-use plastics, and broken HPD things, polypropylenes, all these things, which makes the degradation slower. And 32% of that is in it, mostly like the sand, rocks, all this thing, which doesn't make anything. We just when we happen to sweep and we happen to throw it into the garbage, our regular household dustbin has a quantity of sand into it. So that particular sand is collected as garbage, but it cannot be processed. It is as good as taking it out and just leaving it into the natural habitat. So this is how we need to segregate. So let's just get into municipal solid waste power plant. What is it actually? How does it help in these cases? So municipal solid waste power plant is, as it indicates, the utmost focus will be to generate electricity out of the waste. So the mostly it is treated with aerobic digester where we decompose it and get methane gas and burn it to CHP plant or directly use it for cooking purpose and those things. Pyrolysis and gasification where we get a syngas which can be run again into a generator or a CHP plant or a boiler plant and we can use that. That again is a methodology where we get fuel to run into a traditional power plant. And microbial fuel cells are something which is new in this line, which is mostly like a accelerated decomposition of this particular waste using bacterial function. It is not proven yet, and people are looking into it and to take help of this particular microbes, which are promising. And maybe after a century or so, we might be having a proven technology, and it might be the most preferred waste management system. Just like let's say 100 years back, right brothers were able to just fly 20 meters, and now aeroplanes, the aviation industry has become a pinnacle of transportation. So it's just matter of time. Things becomes more practical and becomes more serious. And incinerator is the common go for most hazardous waste. For example, biomedical waste, the medical waste, waste, all these things will be directly taken to incinerators to completely decompose, destroy it, and generate the heat and take that heat energy and make a traditional boiler. The image which we happen to show is a traditional incinerator plant where the municipal solid waste is completely burnt and it is completely, the heat is used to generate steam and recover it through turbine. So let's just get into how we can do this problem. What is the technology you want to use out of this? Let us get into that particular segment. So engineering a municipal solid waste power plant, the most important thing is we need to set it first, like whether we want to recover our resource for in the top priority or energy in the top priority. So in this particular segment, we happen to, first of all, we have segregated into three different stages: the collection stage, sorting and processing, and post handling. The collection stage is quite simple. We are going to collect the waste from households, all the establishments, all those places, and we are going to take it to our place and we are going to process it. But as simple it sounds, it is not that easy, because we don't know where people will put the waste, how people will put the waste, when to collect it, where to collect it, how much is the waste worth. For example, a person throws up cardboard or plastics on day one, okay, it's with the energy content we can get it back, and the day two he just throws a packet of food, and day three he doesn't throw anything. We are just going there and coming back without anything. So this is a practical issue, and sourcing the college and logistics. How efficiently are we traveling? What is that particular? Because when we put up a truck, we are going to expend some money on that. And how it is effectively got back. These are the challenges in collection and sorting process. What are the materials it will be there, or what are the proportions? For example, someday, as we constantly saying, the variance of plastics as well as wet waste. So how much is it? How are we going to stake it up? For example, when wet waste and dry waste is in a considerable amount, how many technologies, for example, in the same time, can we put up a biodigester as well as an incinerator, biodigester as well as a pyrolysis plant? We need to get into that. And when this wet waste increases, for example, in a season, let's just say the harvest season comes and people happen to throw up more of the organic waste is uh, receivable by us, we need to get into focus on that. Uh, the technology process is highly variable in municipal solid waste plant, and selecting the right technology and right methods to sort it is completely challenging. And the project development. So once we have sorted out what is the technology we want to use, what are the materials it is going to come with, the predictive analysis, all those things, technology selection, site selection, all those things, we need to develop the project and get it installed so that it will develop the work. And after installing, once we process, the power which is going to be taken is going to be handled in post handling, like the evacuation power will be evacuated to the substation, to the grid, or the local consumer, the local communities, user. So it will be taken back. And the next key thing is by product management. The ash, in case of incineration, the ash and the smoke, which is highly corrosive, which has to be treated and it should be reused and managed effectively. Environmental impact assessment, because we are processing waste here. It doesn't mean we are not polluting. We are actually taking all the garbage, we are going to put up into a land yard, we are going to stack it up, and that place is going to have an environmental impact. And while processing, people are going to be there, employee health and safety. After post handling, the waste which is being generated, what is the environmental impact will happen, and during the process of processing of waste, what are the environmental impacts it will create. So all these things has to be taken care, and it has to be assessed in upfront and have contingency plans. For example, something goes out of limit, what is the plan which has to be taken care, what are the factors which has to be considered. All these things will be taken care with the post handling methodologies. And operation and maintenance of the plant. So the plant has to run effectively. This is the most tedious part. It seems like, okay, once we have set it up, all things, everything will run. No, that is when the problem starts. So we need to handle with the stakeholders, the people who work in the employees, the owners, the governments, the local communities. All these things comes into plan when we are operating and maintaining the plant. Any pure operation in the plant will lead to catastrophic failures, which we are need to be taken care of. And literally, people are very hesitant. Finding labor for this municipal solid waste power plants is the tedious one. People are not willing to work in solid waste management, and people want solid waste management. So these are the issues, and there are a few automations which are being taken, but it is not quite proven. These industrial automations are of custom built for suiting that particular need. So there is no particular system which can completely sort the waste completely without any human intervention. We need humans to sort it manually in most of the plants. So that's a tedious process. So let's just get into each and everything in more detailed way, and we would like to explain you on that. So waste sourcing. So where all the what are the sources of waste, and through what we are going to collect it, and how we are going to make a study of that particular waste. So as we all know, the industrial waste, which is in sweet, we can ignore that because it is completely sorted and has high calorific value. It is completely processed with high volumes. Because we get it high volumes, it is mostly locally processed in most of the places. That's part of the thing. The urban waste, residential waste, or dustbins. We just put it onto the garbage collector, and it goes into a larger landfill, junkyard, and it is taken care of. So for us, we believe, and in public places, in train stations, bus stations, airports, we just throw into dustbins. Right? Those particular dustbins are being collected and taken to the same place. And in our residential complexes, and in the food streets and those places, we might have seen the large bins which is lying around in not as the image which happened to see show in the first the common view of India, but these particular bins are there. Now you may have this thing like why we need bins when people are collecting the card. So the thing is this: in a case study, when people happen to put up everyday garbage collection, people have put in early in India, post in 90s, the case was like there will be a dustbin at the end of the street where people of that street will dump into it, and weekly once or 2 days once, the garbage collector picks it up. So the waste management was not so effective, and it was littering, and there were so many issues with the local communities. People are completely fighting on it, and then it came like every day we are going to collect the waste. We'll just put up two people who is going to cross across every street of India. They are going to collect the waste, and it is going to be taken care into a landfill. So this was quite promising because people every day morning, it was not going to be lying around in their community, and it will be taken care of. Then now it came the practical issue. People were producing the waste uh, more random than what they predicted. For example, a person comes and takes up into the card comes, the home one will be having zero waste. Home two will have the waste enough to fill the entire cart. Home three, the waste is not going to be filled. So this is how it was. So the variability was very high. People were not able to find effective logistic systems. We cannot put up a compact day on that day alone. It should be, we don't know. People have came here. So this particular issue happened to start, and people were like, when this goes off, and when people were missed the time when the garbage collectors just skipped that, the garbage has to go somewhere out, but out of their home. That's the first priority, right? So just pick it up and throw it across the street. Same place, same location where the dustbin used to lie, now has become a garbage yard in everyone's community. So what now people are government is doing is they are putting up with bins in local communities along with this. So once you have higher garbage, you can just put up in that litter bin, and that litter bin will be taken care by like after 4 or 5 days or a week, or based on the community, they make a schedule on that, and it will be collected. The littering, as of for littering, if the littering was done in a place where the municipal workers are cleaning or something, it can be taken care of. If it is in completely off remote, it is not recovered at all. That is the case for it. And agricultural waste, as everyone knows that it is taken care of, and you don't need to worry about much on that particular segment in case of municipal solid waste. So now coming to this particular sourcing, how are we going to route? For example, residential, a person goes to collect in residential, and he comes to a complex place, it has a different one. It's altogether a big one. So how are we going to use it? A person comes into a cart or goes into a truck or gets a compactor. When to choose one? Where we can get a compactor to recover the waste. So all these things takes huge amount of calculations, most amount of study to be done in that particular locality. For example, dry waste is the compactor, as the name implies, it compacts, it compresses the waste. We all know water is incompressible, liquids are incompressible, liquids cannot be compressed. When most of our waste is into organic, we cannot go by a compactor and get it, because as we happened to see earlier, more than 50% of our waste is in organic. So compactor doesn't really make sense in taking into residential segment. So residential segment, carts and pickup trucks. So where carts are used in places where very less, maybe around like the household generates around 2 kgs of waste in that particular street, around like let's say 20 or 25 houses are there. That places this carts may work, but if it goes higher, we may need to move on pickup trucks. So we need to efficiently route according to the what is the optimal path to use the least resource and cover the all the places in lesser time. So time, distance, and the quantity. All these things has to be charted, and we need to draft a plan for effective collection of the waste in municipal solid. So now we have collected it, we have made efficient plan, we have all these things, and we have done it. So the next step is sampling the municipal solid waste. Prediction for resource. What is actually there? What is that we can get? We can chart it out. For example, our day of the, for example, the last year we happened to get so and so materials from this particular home. This is how it varied. We can get into a linear derivation, and we can predict like the upcoming years. This is how much wet waste can be expected from this particular. This is how much a dry waste can be there. This particular predictive study at least takes a year long, or it goes higher based on different communities. When the communities come in, for example, in urban, due to this urbanization, people tend to move from rural areas to urban, and they impact this supply chain. They tend to purchase different things. Their lifestyle is different. They are adapting to this new lifestyle. It will increase the thing. So the urban lifestyle and this migration, all these things will constitute this waste management. So we need to study on that over a year. What is this particular area's waste pollution which has been generated, or what it is expected in the next few years. All these things has to be taken care before selecting what technology and what is the processing method we are going to take. So now we have known like, okay, this is how much the calorific value of the waste we are going to get. So much plastics will be there, so much metals will be there, so much organic waste will be there. Now we want to get into how we are going to sort it, because everything comes into the same bin. Everything comes from the same person. It's not going to be separated. So let's just get into it. So recovering valuable resources, the first thing, because steel, aluminum, all these things, we can just recover it and we can just give it to, we can just sell it to recycling companies so they can just take it, and we don't need to go to the entire process and give it to them. We can directly give it to them and we can make a dime in the initial thing. And we will collect mostly, like most of the cases, we may not collect this aluminum or steel. Most people will tend to sell it themselves to this local recycling person. They will get the benefit out of it. In municipal solid waste, there will be a very limited amount of metals or zinc or other material valuable resources which might be there. You may not be considering. You may even find some gold or silver in some cases. It is quite possible even to get even diamonds or platinum. The most precious metals, we may get it in the garbage. So all these things will be recovered in a separate way, and we can take it out. But how to sort this? So the collection point we will just put up, like for example, industrial waste stays here, and the residential waste stays here. Residential waste from this community, for example, a lively community is like a commercial street, is put up in one place, because that has a different set of waste. A place where there are so many hospitals, that waste is different. a place where there are so many restaurants. That list is different. Only residential segment is there. Pilgrimage segment is there. So all these things has different segments based on the calorifical of that particular zone. So we will just make the yard design and we will use that particular handling equipment. For example, whether we need a bucket excavator or we need a crane or we need to have electromagnetic lifter. All these things is based on that particular waste which has been sampled. And after that, most of the waste people just tie it up and they'll just throw it into the bins, right? So people will not open it, or like it makes the process more tedious. People don't want to sort it. What they'll do is they'll just tie it up. They don't at least give it in a freeway. So they'll just tie it up, and inside it we don't know what the hell is there. And people are hesitant. No one wants to open other person's garbage. You can just keep it there. The most safest thing is other man's junk. No one wants to open it. So that is the place which has to be open, and manually no one wants to open it. So we put up a bag opening, initial screening bag opener will be there. It will just take it out all the things, and then get into large object separation. For example, visibly large objects, like for example, someone has tossed away their mixer grinder or something. They have someone has tossed away their phones. The larger objects can be taken out easily from the garbage. So these things will be completely taken out and it will be completely put up into other process, respective process. And smaller ones, let's just say it is less than a half feet or like 6 inches small. So less than that things has to be processed. So what we do is we take those things and put up into a manual sorting. When it goes into a manual sorting, people just pick things like as we speak like this, plastic bottles, a large bottle, all the things people tend to pick it up and put up in different bins, as which has to be done in the collection stage. This all be done in the sorting stage. And once this manual sorting is done with very small, tiny objects, let's just say around 1 inch or half an inch objects, which cannot be recovered in manual sorting too, because people cannot keep on taking that, and just consider like the waste consists of everything, the organic waste and everything. So people don't want to put their hands into that. So larger one they will just take it up. The smaller ones they will not intend to pick it up. So that goes into different types of sorting mechanisms, like the magnetic sorter. That's a traditional one. People we just put up a magnet and we'll take it up. But magnet doesn't attract all the electrical, all the metals. So we need to have a different electromagnet eddy current sorter, which will just pick up all the metals. So we'll take that and we'll shred this thing and again do the same process. Then again go for this inert metal. So in this, when we put up in a lamination, the mud will just fall off. All these rocks will be there, and we'll just put up into a cyclone sort of like the wind shifter we call it. So through that we'll just put up into it, and there will be a cyclonic wind which will be taken care of. Due to this wind, the lighter particle based on the wind force, the density of the waste, the rocks will fall at the bottom, the glass pieces will fall at the bottom. All this thing, with this, we will take out the, we will sort with the particular waste. The plastics will come out of one place, the papers will be going out of one place. All this can be sorted. And this entire thing, once it is sorted, we will take it to based on energy current. For example, the waste system is completely going into the compressor. We will compress it and remove all the water current first. Take this to a buffer zone, completely dry it, and put up into a digester. Take this completely water into Balena filters or STP filters and process that particular water and reuse it to gardening or some other purpose. The organic waste sludge which was recovered from this compressing the organic waste is put up into digester, made it to decompose and take a manure or get the methane gas for CHP plant. So all these things is being done in a different way, and in the same place when this or the plastic, the halocalorific one, is being taken and it will be stored across, and it can be taken to a incinerator. And then this particular is most of the plants, this sorting machine, sorting mechanism, and all these things will be there, and this particular digester, the um, complete things which was sorted out will be compressed, shredded, and made into something called RDF, reduced diffused fuel. We may see it as pellets, which can be used in or hotels for instead of firewood. All this things, we will just burn it there. We'll take this. This all depends upon the calorific value. Whether the calorific value goes beyond 1200, it is as so good that we can burn it directly into an incinerator or boiler or something. We can use it. But if it lies between 800 and 1200, the calorific value, we may need to use some coal to mix up with this. So that has to be again taken care of. Coal has to be mixed with it and made a pellet, and that has to be taken care. If it is less than 800, the calorific value is less than 800, it goes into a different process. So based on the calorific value, we will just sort the technological system which we want to process, and with the quantity as well as the calorific value. Both decides what are the systems which we are going to put up into it. Once we have sorted everything and we have put up into a place, we'll just next get into technology. Like as we said, there are many things. Incineration, whether we want to go for incineration, digester, or pyrolysis system, or microbial fuel cell, all these things will decide on the recovered quantity and the calorific value. When it is very less, it's organic completely, we will just get into a digester, anaerobic digester, which is biochemical conversion, which converts the complete waste into methane. So a digester can take into liquid as well as semi-liquid waste, like this cattle waste, plants, the organic waste which we have throwing out. That can be digested in an anaerobic digester. So that is completely proven. It is simple, it's modular, highly flexible, and cost effective too. And it can be set up so easily. And that is where most people prefer that. The next thing which is on the line, the next preferred one is pyrolysis. Pyrolysis is the thermochemical conversion where we pass heat and steam to decompose that particular waste in an inert environment. So once it is decomposed, we will get something called syngas. So this syngas can be used in CHP plants or a boiler to burn in a traditional way and just generate steam, and through the steam we are going to generate electricity. So this system may be quite easy to explain, but the system when it is being constructed is so complex, and it has very less flexibility. So because we are going to provide heat and steam based on the calorific value. When it varies a lot, this particular system may or may not work, because it has been proven in industrial waste and farm waste. It has been proven biomedical waste where it is the waste is always the same. When the waste is variable, like the municipal solid waste, it is not that proven to use a pyrolysis system. We need to have a complete regulated, more charted mechanisms for using a pyrolysis one. And the the least preferred one, and most people think like, okay, we don't want to get into it, is incineration. That is where it is completely thermal conversion. It doesn't get you into anything other than heat energy. So the complete waste is burnt. Either it is directly burnt, as we happen to discuss, the calorific value is 1200. If it is not 1200, the color we are going to add coal to it and increase it and burn it. So that through that we are going to recover the heat by producing steam and running it into a turbine, and as a traditional power plant does, through the generator to the evacuation, also the AC systems also. But here the system is highly complex. The incineration, when we are burning just one particular material, we will design that particular boiler or something to suit for that. For example, a coal boiler will be suited to burn only the coal of that calorific value. The metals which will be used is used to withstand that amount of heat energy. but we cannot use coal in a boiler which was designed to run in firewood. Firewood doesn't create that amount of heat energy, so it will literally damage the boilers. So that is the kind of issues in burning a particular waste. The calorific value gives out different amount of heat content. So this with variable heat content in solid waste, we cannot possibly think like, okay, we can just burn everything whatever we want. It should not damage that particular equipment, and the recovery rate of that heat should be high. So for that purpose, we still need to attain the factor where we put up the energy to burn that should be efficient enough to recover the amount of energy. Incineration is mostly used in eliminating biohazard waste. So that is the most proven system which people use. Like they'll just pay for it and they'll just destroy it. They don't worry about the energy recovery. But this can be a solution for complex and more uh, variable municipal solid waste. But still, there are so many innovations to come up in incineration segment too. And the other thing was microbial fuel cell. Microbial fuel cell converts this particular waste, organic waste, through bacteria, decomposing the waste through microorganisms. It's mostly in research phase, and people are working on it. As I said, maybe in the upcoming century, this might be the most preferred method of waste processing, where we can just get the organic waste and process it so silent and so easily. We don't need to be worrying about huge machines or anything. We can just put up a few microorganisms, and that will do the job by its own. So, anaerobic digester. So, anaerobic digester is one method of recovering heat energy by getting a natural gas and running it to power stations. So as the image indicates, we get manure, we get methane and natural gas for running our vehicles or powering our homes. Then running a heat engine to get electricity to meet our needs. So all these things can be used. But the problem with this is the system is not so efficient. It's almost the efficiency of energy which is recovered is around 50 to 60%. We cannot recover much of energy from this. And this particular methodology is mostly depending upon the volatiles. How much organic, how much carbon content is there? To be more specific, how much carbon content on the digester we have put up into the digester. So this particular thing needs mostly monomers, and decomposing that is a long process. We may need to induce artificial microorganism, like artificial methods of increasing this particular output. So this is not suitable for urban waste because most of it is not homogeneous and mostly it is dry waste. Most of the urban wastes are dry, and we cannot see any. That's why I happen to say, like Chennai doesn't have any biomass power plant because Chennai is a metropolitan city with complete zero biomass feed. There is no biomass feed at all in Chennai, so that there is no biomass power plant in Chennai. So gasification of pyrolysis process. So this is a traditional setup where we are going to input hot steam and air and completely burn it in a inert zone. We are going to completely heat the waste into it by decomposing it at a higher temperature, say around like 1100 degrees Celsius, 1200 degrees Celsius. We are going to heat it completely just like a furnace, and the entire waste is going to vaporize into something called syngas. The syngas is being used in syngas generators or there, syngas power plants. You can take it to burning into a boiler, or you can just use it into a gas turbine power plant or something. You can use to generate electricity out of it. This is mostly used for agricultural as well as organic waste with calorific value should be there, maybe around 800 or 650 or 800 calorific value. If it is there, at least we may get into this technology. Or if it doesn't have that calorific value, we cannot get into this particular mechanism. When there is a huge amount of water content into the waste, we cannot go by this pyrolysis methodology. The pyrolysis methodology doesn't work by that. We may need to be putting into more energy than what we are getting it out. And limitations of that is it is not proven in urban methodologies. The urban waste is not proven still, and it is still under development because of the varying content in urban. Processing it is a highly tedious one. So incineration process. So incineration process, as we happen to see, that's industrial development. The garbage comes, it is sorted. The whatever we have sorted, it comes and puts up into a pit, and the waste is fed into a conveyor, and it is pulverized, and it is going to be burnt into a water tube boiler, and this heat is going to be recovered through water tube, the water running through the water tubing, and it is going to run a turbine, and it is and the turbine is going to in turn run a generator. Through the generator, the AC subsystems with the LILO, all those things, and we are going to evacuate to the grid. That is there. But post handling, so the ash is being the ash which is being generated out of this is highly tedious. It's not a homogeneous one. The ash um, properties are different in this particular case because it is not completely purely carbon alone. So this particular ash is going to be used for some other purposes. Like for example, we are going to we may make it fly ash bricks. We may get into cementing construction activities, or we can just use it to landfill application. For example, when there is a place where we have where a mining has been completed and it has to be closed and it has to be recovered, we can just put this ash up there at the ground, and we can just fill up with the sand and those things, and we can develop this landscape. That is one of the method. And this particular uh, ash, the smoke which is being burnt, is corrosive too, um, which has high amount of sulfur content with nitrous oxide, sulfur dioxide, carbon monoxide. All these things will be huge. So this has to be taken into a separate scrubbers and complete catalytic converters and many other such things to effectively take it back into the environment. So, so incineration process is complex. It involves high initial cost and it has environmental impact. So, and considerably the efficiency is around 85 to 90% of the waste can be processed and we can take it out. But out of this, the calorific value is, as we spoke, is the key factor. If it is not having any enough calorific value, we cannot use it. Maybe I think people may think like, okay, why we want to have this? Like when we have processed this particular waste, why can't we give it to existing thermal power plant? You can just instead of burning coal, they can just burn this. It is quite simple as we speak, but it's not that easy because as we speak, the calorific value decides the flow rate of the steam generation quantity, as well as the steam output, the plant output. Everything depends on the calorific value of the coal. Gets the coal parts because this is a variable calorific value. This cannot be directly done like that. This has to be studied and increased. It has to be sampled, and every time it has to be checked for the optimal calorific value, and it has to be done. So that is the additional process. And along with that, the most preferred one is taking this particular processed waste instead of taking it to this incineration plant. People usually they just pelletize it and take it to restaurants where they use this boilers to generate steam in a variable basis. So those places they will give this pellets and the pelletization process, which is used to generate this RDF fuel, reduced diffuse fuel, and that can be used. And that this particular RDF method ensures the waste and the coal are mixed in a proportion that to ensure the calorific value stays in particular zone, like say around 1150 or 1100 calorific values. So this particular RDF can be used in power plant systems to burn instead of coal. So that is the viable option. So microbial fuel technology. So microbial fuel technology is an emerging one. So this is, there are many methodologies which people are working on using it. This is one of the electrolytic cell-based microbial electrolysis cell. There are people who are working on having a sand pit using the microbes and using a solid state setup. So we are like not many are quite sure like which is the most optimal pattern, whether to take it into a liquid phase or whether to take it into organic phase. So in this case, mostly we get is H2 hydrogen as we are looking into it. Hydrogen as a clean fuel, we get this hydrogen. We can just use this hydrogen into the traditional fuel cell. Traditional fuel cell which uses hydrogen and steam to generate electricity in a fuel cell vehicles as well as the fuel cell power plant. So we can use this hydrogen as a power. So this is what we are going to recover from microbial fuel cell. This microbial fuel cell is mostly focused on bacteria. So this bacteria which is being taken onto this organic thing, and there are certain conditions which we need to enter. For example, the pH of this particular waste, when it is in liquid phase, the pH should be around 7 for the microbes to survive in it. So there are many limitations into it, and still it is emerging, and there is not a proven methodology for processing this particular methodology. And this is a place of innovation, and we can get into it. So once we have processed our waste, we have selected technology, we have processed the waste, and we have done all these things. Then comes the biggest issue of all, handling the byproduct. In most of almost all of the power plants will at least have one or two of this particular um, byproducts. So let's just say a biomass digester, anaerobic digester will have a sludge with it, which has to be taken care of, and the leachate along will also be there in the digester. You take out that liquid things too, and recover resources from the sludge. When we are processing, like we have recovered materials, the required resource will be there in almost all the plants, which was earlier recovered and which can be sold to recycling industries, like the uh, metals mostly can be steel or zinc or aluminum can be sold to the recycling companies and can be recovered out of the money can be recovered out of it. The sludge, when it is completely organic, the biogas digester, it can be utilized as manure by making it, completely decomposing it and taking it to the landfills and using it as organic manure. And the leachate is mostly treated with ATP and STP plants. It will be employed in the solid waste handling plant. Just recycled water will be not fit for drinking, so it will be used for gardening purpose or watering the plants and those things, because the microbes doesn't really die much into it. This particular incident, as we happen to speak, like the Surat incident, which happened to lead for one of the largest plague attack in India was in Surat. That was the case. This has been in many communities where the leachate, the microorganisms has affected us. So this has to be taken care. We cannot directly open it into water bodies near to the site, or we cannot just dilute it. We need to process it, and then we need to take up this particular. When it is processed, that will again generate a sludge into it. So that sludge has to be taken care of, and which will be mostly incinerated if it is more high toxic. Based on the toxicity level, we are going to select the technologies which we are going to use in the post methods. The ash and smoke, on the other hand, is the ash can be delivered to construction companies to generate fly ash, bricks, or cement, or those things. And this particular smoke is highly toxic, as we have been discussed, and it has to be treated before letting it out into the atmosphere. So these are many. These are the few of many different problems which are being handled in municipal solid waste power plant. You cannot just like okay, a municipal solid waste power plant is not just like okay, we have this particular garbage being collected across the streets. Yeah, people are paying the amount to be collected, so we get the money in tipping fee. We'll get that. We'll just burn it and we'll get the energy and we'll just going to sell electricity. It is the most common myth about the municipal solid waste power. People think like, okay, this is so much so simple, it is so profitable, but it's not the case. If it is poorly planned, municipal solid waste may become a disaster, but it has to be planned precisely. Once it is planned a precise manner, and if it is completely organized, municipal solid waste power plants are almost like a gold mine. Can get uh, the, the recovery rate of resources in different methods. The recovery of resources, because as we have been said, there are quite a very lot of resources which is lying around in waste, from metals, gold, silver. We get diamonds, everything we may get it there. So almost whatever human uses in the present day can be found in the junk. So that has to be accounted. What is the actual waste? What is the percentage of zinc? What is the percentage of copper we are going to get out of it? What is the percentage of plastics we are going to get out of it? All these things, when it is perfectly planned, we can make a very good profitable plant when we are going to design it. So once we have studied it, okay, we know this is the technology we are going to do. These are the particular methodologies we are going to do. So we have got the knowledge now. We are going to we have seen it, how we are going to take the waste, how we are going to process it, what is required. We have understood the waste completely. The raw material is understood and the technology is understood, and how we are going to put up into a practical thing. Okay, we know how it works, but it doesn't mean it is going to get paid. So we need to get a team of people working on that. The first thing is stakeholder approvals. Local community should accept for processing the waste. Government norms should allow us. The municipal solid waste norms are there, which has to be addressed with the pollution board, which has to be addressed. All these stakeholders has to be looking into it, and the shareholders, the person who is going to purchase the energy, the person who is going to own the plant, who is going to run the plant, who actually employees in the plant, who is the employees of that particular plant, all these things, the buyers of that recovered resource, buyer of the power, all these things has to be taken care. If everyone comes into play, like the person who willing to buy things, who is going to supply things, the government should be readily available to supply us the waste. In case the government systems are not efficient enough, we need to look into ways where we can, as the body itself, the processing body itself may get into the community to collect the waste, or may equip some non-governmental organizations or self-help groups to collect the waste. All these things has to be played in the very first role. Who is going to collect, which particular division, what is the scope of the collector, who is going to collect it, who is going to get it to us, what is the scope of which we want to do, how much energy is going to be sold to the power purchaser, what is the actual amount government is going to pay us in the terms of tipping fee, what is the actual amount we are going to put up front in the capex. All these things has to be taken care in the upfront phase, and everyone should have agree that this is a particular thing. So as all these things, once everyone has agreed, then we want to get into environmental assessment. We need to get into a site. We need to check for the things. Okay, this particular site has what is the flora and fauna content. For example, what is the plants, what are the species that are getting here. If it has some forestry background around it, is there any intervention of forest animals in this particular place? Is there any intervention of rare species, intervention of rare animals? All these things has to be taken care of. We cannot mess up with that because we are going to focus on municipal solid waste is to be considered as waste pollution solving one, and we cannot end up creating it more. So this has to be taken care. The environmental assessment, once it is being completed, we need to select multiple sites in environmental assessment in that particular locality, and then select a site which is very cost effective and easy in logistics. The waste which has been generated has to be taken care, it has to be collected, and it has to be transported to the site. The site should be the large enough to accommodate the waste which we want to process, and it should be prepared. The site has to be prepared, right? The site has to be prepared in site preparation. We need to consider this particular requirements in site selection, how much it has to be prepared. For example, if near a water body, what are the measures it has to be taken? If it is near local community, what are the measures it has to be taken? All these things has to be worked on it. And local communities should accept that particular site. So people are okay when we go on say like people we are going to process your waste, we will eliminate your waste. Yeah, okay, happy, I agree with you. We are going to do it next to your home. No, I don't want to do it here. You take it somewhere else. I don't want it here. So that's how people are, right? So the local community should accept to that and access to substation. Once the particular power is being generated, the purchase should be near the purchase. If an industry is going to purchase the purchase, we need to excavate it to the power to the purchaser. So again, all these things comes into place where this optimal location, what we can trade off, what are the things we need to find a location where the operating cost of the plant will be very low. So that is when we have selected that location, that is when we can go ahead and we can just get with the next process. So the next thing is supply chain. As we happen to see, who is going to collect the garbage. So the garbage should come into the play. Once we have set it up, okay, we'll process when the garbage comes. That doesn't work like that. We need to have efficient supply of that. We need to get entire garbage supplied to the site effectively every day, so that the plant can run in the optimal capacity for delivering the electricity to the particular person. So once we establish this particular supply chain of people who collect the waste, who happen to give us the purchase the power, all these things, how we are going to the right of way for that, and other recovery metals, whatever metals we have recovered, how we are going to transfer it to some other companies which we are going to sell it. So all these things has to be taken care in the supply chain. Okay, that we have, we have got approval, we have made assessment, we have got a site for ourselves to put it up, and we have made with the supply chain with all the things. We have got methods to get the waste here. We have methods to dispose of the after byproducts. All those things we have to make all these things. It is all done now. So now the next phase is construction. So now we have all these things. We have construction phase. We'll design and engineer. These are the systems. This is how the layout should be. This is where the collection node will be. This is where the sorting section will be. This is where we will process. These are the technologies we will be processing. All these things we have to put up. Now we are going to put up all these things, make the site preparation, excavate it, prepare it, prepare the junkyard with leachate protection, all the chemical treatments which has to be given to the yard. All these things we are going to do it, and then we are going to make a effective stormwater systems to collect the leachate, and how we are going to process that leachate, the STP plants, CTP plants, then installing the sorting systems, putting up with the plant technology. So when we are going to put up with heat recovery, like boilers or something, how we are going to put up and what is the segment it is going to have, and all the norms which has to be taken care, and the electrical segment where the electrical subsystems, all the things will be there, that has to be put care. And all these things once we happen done, and we are going to track this project day on day, as in every other power plants. when is the raw material will be available, arriving on the site. For example, today this particular machinery will be arriving on the site, so this particular machinery has to be fixed in so and so just in time, as the Japanese use just in time. So we cannot um, use a large warehouse for a temporary purpose. We cannot put up all these things. So we need to prepare that temporary warehouse. We need to get all these machineries, get in there. We need to fix it up, put up the roof, everything. And once all the things are done, we need to make the testings. We need to test run it, trial run it. Okay, we need to check it out. What is the output? What is the rated output? We are going to get put up a temporary load, and we need to see that. Once everything is completed, then we need to go with the government approvals, all the pollution board approvals, all those things, completion reports, everything we have just got it. And once we have done everything, now we will turn it on the plant, and the waste should reach there, and we need to wait for the waste to reach a buffer stock. For example, let's just say when we put up a coal power plant, we use around 40 days of coal in the coal yard. So that is to ensure the regional availability. So this particular garbage is not as industrial commodity. It is a highly variable commodity. We cannot get, we cannot expect how much we should be keeping up into the yard. So in order to maintain that, we need to get back to our studies. So we need to see that how much quantity, what is that, how much days, for example, do we need to keep it up to 180 days? The worst case, 180 days is the most worst case. People will stack it up in the municipal solid waste power plant. 180 days of junk should be there. So 180 days of junk, how much space it will be. So 180 days of junk, once it has filled, we need to getting into the process, and we are going to process and keep something. For example, something fails. Again, something fails in a sorting machine, we need to wait for the replacement time. For example, the lead time of the plant replacement part. So this lead time of the plant uh, thing has to be there as a floating stock. For example, in it, I am comparing it with thermal power, because most of it gets into that, because the thermal power plant has 8 hours of floating stock, because within 8 hours they will have a spare to replace it. So they will have a 8-hour silo, which is, and the coal is will be completely pulverized and put up into a silo. In similar way, the completely sorted and ready to recover fuel should be there in a temporary yard, which is having a temporary flotation stock, which we call. So that has to be calculated, and once everything is done, the flotation stock fills, then we are going to commission it, and we are ready to generate electricity, and we are going to take it. So once we have started, we are generating electricity, the person is getting the money, and the electricity is going on. Now the thing is running it efficiently. So now the everything we have so far done is a one-time thing. We have done it. Okay, we have done so far. Now the biggest thing is maintaining the operation. We need to get contingency plans. For example, a person doesn't come today, we need to have a contingency plan. That something breaks up today, because we are handling municipal solid waste, there will be hell lot of surprises than a normal power plant. So municipal solid waste power plants is almost about load stabilization, because the calorific is highly variable. The steam output is again variable. In case of steam, or the syngas which is going to be generated, is all highly variable. So we need to have buffer stocks. We need to have temporary storages based on the stocks. We need to. This is what makes the entire system more complex than other power plants. So we need to have stock for every other segment. We need to store some fuel for burning into the plant from the sorting. Once we have recovered the resource, for example, we have used it to pyrolysis, we are getting the syngas. Syngas has to be stored as a buffer stock, so which can be used for running. In case we are trading the syngas itself, it's not a big deal, no problem with that. But in case we are going to get into a power plant, we need to convert. We are going to sell electricity, so we need to put up a syngas storage unit too. And that again with its own environmental impact and its own storage implications, it has to be taken care of. So all these things is a labor intense process. We may need to put up more labor, just like in manufacturing industry. So all these things has to be managed day in day out basis. What is the amount of plastics and the waste quantity which happen to arrive today? So that has to be recorded on what it is going to be. The byproduct which has been taken care of, and it has to be accounted every day. The air quality has to be accounted. What is the effluents we are going to put up out of the plant, what are the things, how much water it has been taken in, water which is going to be audited out, energy auditing, water auditing, environmental auditing, everything has to be done day in, day out. So that's what makes the operation of the municipal solid waste power plant so tedious. So we have done all these things. So now you might be thinking like, okay, so many things, so many works, everything we have done, and we have processed the waste. What are we getting out of it? So let's just see one of the most one thing. This is indicative one. This is not for any of the actual projects which we have employed with. So this is a typical one. Just for a small comparison, we are just showing it. It's not a actual costing thing. So let's just say we are going to process 300 ton per day. This was we have considered for a 20 megawatt uh, power plant. So we are going to process 300 ton per day. So tipping fee is around $30 per ton. So we may get around $3 million out of that annually. So the $30 per ton is annually for an annual basis. So this is what we are going to get. The PPA, power purchase agreement, is for 10 cents. We are going to sell that particular energy for 10 cents, they around like 7 rupees, 7 Indian rupees. So we are going to sell it to a unlimited local. It's a great. So cost of the facility, initial setting up, maybe around 35 million. So we are going to put up an incinerator here. We are going to put up a sorting plant. We are going to completely generate the output is completely from the electricity. So this has been taken care, and the labor cost, for example, as we happen to say, it is labor intense. So, but we have considered most of the automation systems, and the least amount of people which we are going to employ is around 20 members at least to maintain this plant. So these 20 people may contribute for $1 million every year, and maintenance cost. Hoping nothing goes wrong, just a mild repairs and so on, we have considered 140,000 so 140 grand. So return on investment. So total actually what we have made. So the income is the expenses. So we are spending around like 1.1 million every year, 1.18 million every year on labor as well as maintenance costs. So because we are going to get a tipping fee, the raw material is being given to us with a cost to process it. So that's a good deal. But this depends on variable regions, based on the local governments. It doesn't actually depend on like, okay, everyone uses this particular pay. No, not like that. So every country, every region has a different pay systems, different tipping systems. Some countries give it, some countries doesn't. Some countries there may be places where we need to pay for the waste. When the calorific value is very high, we may need to pay for the fee. So those things are those implications. We need to work it out on the upfront initial project plan stage. So all these things they may get the ROI in 4 years. So the typical power plant ROI, return on investment, the 4 years we may get the return on investment. Yeah. In a meeting club. So, sorry for the interruption. I think there was a network issue with the presentation. Um, yeah, so that's what I'm going to see with the complete. So this is what it is. Like we happen to do all these things. We are making all this planning, the cost analytics, the design phase, the study phase, the technology selection, the project management. All these things has been done by Phovesto Power, so few of the plants across the globe. So there are many more things, not just about having the right technology or having the right sorting methods or not having just the supply chain. We need to more than that. So all these things will be made in an actual real-time power plant. So we are actually looking forward with the PiHub to conduct our own training sessions for through online webinars or something for different type of power plants which we are delivering our commercial solutions across the people and across the globe. So I think I'll close off today. We happen to give this thing, so we may get into the feedback form and we may check with the questionnaires. People have posted anything out of it. So I think there are guest traps. In the capex of 35 million USD or 30 million USD power plant, 30, are all considered or financial costs are included. Yeah, this is just a typical cost which we happen to consider. Yeah, Mr. I think this is from Mr. Winkle. We happen to ask whether we have considered all the cost pertaining to the capital. So we have considered it as a typical rule of thumb cost. This is not the actual cost because we cannot put up a imaginary cost. We cannot say like this is how much cost it will be unless we work it for a particular plant in a particular location. So if we happen to work on, like for example, in Delhi, the waste is a different way. The tipping fee may be there, may not be there. To check with the local government how effective the system is. In case if that particular system, what is the actual cost which is going to be taken care in case of procuring the waste and the sorting methodologies which we want to consider. So these all the things has to be considered in terms of a actual power plant. So this is just a rough estimate which we are giving as a rule of thumb we are going to showcase. So that is one of the things. So any other place? So I think there is one more question. Why are we not using sorted dustbins in India? We are sorting only 3 dust, but in Japan it's 12. Yeah. So sorting, people. I think this is a important question we are having. India is a different scenario. For example, when we are speaking about Japan, this particular village in Japan, where the waste is being sorted in 12 different categories. Yes, right. 12 different categories. People sort it into 12 different uh, waste, and it is being recovered and reused completely into that particular village. And that particular village has zero garbage. That's what they claim. And most European countries have 6 different methods of sorting. But in India, as we happened to say earlier, using the dustbin, first using the actual dustbin itself is the biggest issue. We're not able to um, make any people worry about the waste. As we happen to see, say like, okay, um, what doesn't what I don't see doesn't hurt me. So that is actual case which people are living in India. Like we are not aware of much of the system and the impact. Actually, I happen to say like the Surat is one of the cleanest city, and they are the very foremost people who happen to get it because they happen to see the pain of not handling it and having a issue with it. Issue with the waste or poor management. So they happen to change. They happen to change and they're improving their waste methodologies. That is how people should get into it, and they need to see the aftermath, the effects, the issues of having. For example, now the COVID situation has started. People have started to use more amount of masks and sanitation, personal protection. All these things has become a very big awareness. People are looking into it, but we need to look into the same factor. Like, okay, once it is being like this, then we are going to discard this based on what is the waste which is going to make this problem sound, or we are going to go about it. That has to be taken care of. So that awareness has to be given from many to the people of India, the common people of India. That is when we can have organized waste. That can be. It is not that it cannot be done. It can be done, but it takes time. In Japan, how effective is waste handling? So Japanese systems, the waste handling, what they believe is zero waste system. So they don't want any waste. They have very stringent mechanisms in auditing it. So they go by like how we are going to actually generate it. They account it. Okay, how much to be frank, their pins are so they are innovating the pins so that it will connect with the IoT. So, for example, this is like the Vision 100 or 150. Like for Japan, what they do is this particular pins is connected with IoT. The IoT is going to indicate up that using AI, they are going to make effective plan, like the routing method and what is the actual system they need to carry out. So that is the system. That is the kind of management system they are moving into. They are into way old into. They are getting into like IoTs, and in India we are like we are still struggling to get awareness on waste management. So that is there, but still those people, everyone is learning this. But we are moving forward, so we can expect that soon we too will be having systems way better than anyone else. Just it takes time people to realize what we want. Once we happen to get what we want to do, then people are so convenient enough. Like, okay, this is what we want to do. So this connected devices, and this is again a innovation place where students can get into one. They can think of a IoT solution where this dustbin can communicate with the effective plan for this garbage collector. Once this particular person says, I think there is one more person which we happen to see this particular idea was one more a student happened to work maybe around like 2 or 3 years back. He happened to say that this was the idea. This was not ours, actually. It was one person's idea, and that particular student happened to start there, and they happened to end the same place. They were not able to. There were the practical issues. For example, what he thought is we can connect it to a community dustbin. But we have seen the first image, the community dustbin which was there, was lagging like it is. So that is the kind of thing which is not clearly managed, and people destroy it. So putting up infrastructure outside into general public, people needs to be aware of that. There are people, the good doers, the bad doers, both of them. So we need to work on that. So this particular systems can be how these are the places of innovation. How can we work with people to get what we want? These are the things which we want to improve on. So, Ravi, I think this is a good session. Will this will and have learned how we have an opportunity to convert our waste into energy. And this consideration should be taken care of many private organizations and also a government organization. When it comes to a clean building, when we go into any office buildings, the ambience is very good, right? To make that ambience very good, we have to, in the opposite direction, we have to also convert these kind of waste dumps to be processed well. So, and this session has gained us many knowledge that we have to see through it. And thus, from here, we are signing off. You can just leave your feedback in the forms which we have mentioned in the chat. And, uh, and thus, thank you from host to team, and we will see you in the next live event. And we are planning it to be more interactive between our technical persons, and it will be very fun for you guys to learn more. And thank you so much, attendees, and see you soon.